talking about the working of toolmaker's microscope. I have a small experiment. The aim is to just measure the this thread specifications like depth, major diameter, minor diameter, and so on, and we'll compare it with the standard values. And coming to the setup, and this is your toolmaker's microscope. This is vertical column, and this is your front slide micrometer. This is cross slide micrometer. This is your eyepiece, and it's your optical head, and this is your table, workpiece table, or whatever. And you have this rotating disc here so that you can alter the position which suits your eyepiece. And you have one more measuring. You can see the 360-degree measurement here. It's called the eyepiece protractor. So it's used to measure the angle between two crests of the threading angle. And inside this you have a hollow. You have a bulb here, and it's completely hollow, such that the light comes out, and you have a transparent glass here. So let's on this. You can see it's switched on right now, and it's already focused, or else you need to focus it. Now, and when you look at the eyepiece, you'll be looking something like this. These are reference lines that you see on the eyepiece. So, and when you, as you can see, the thread is placed here. So usually the light gets blocked. So whatever you see in your eyepiece is actually not the thread, but the blocked out image. That is the shadow of this thread. So when you look at this and looking at this shadow of your thread, you'll be measuring the major diameter and minor diameter and so on. So coming up to major diameter, when you see something like this, when you look at the eyepiece, and the crust to crust will be your major diameter, and trough to trough will be your minor diameter, and approximate center of your this will be a pitch, and the angle between this thing will be your the thread angle or something. And as you can see, this is the reference line that you see. So when you focus it, you'll be having something like this. When you look at something like this in your eyepiece, so considering this as your reference line, you use when you okay, let us consider I'm measuring the major diameter right now. So you have this thing right here. So when you make sure that this is the topmost line is touching your crust, and you need to use this front slide micrometer to bring this line to this. And before that, you need to get to know the least count of this micrometer. It is 0.01 mm. And you need to, after placing this line here, you need to check the value. It's around, right now it's 3.4. It's 3.4 mm. It's showing me 3.4 mm. And you'll use the
least count. Least count is 0.01. So it cannot be 3.4. It should be 3.40 or 3.41.
3.40.
3.40. Okay.
And now you'll look at this, and you'll bring it's 4.28 mm right now. 4.28. This is the initial, and you'll bring this line to this line by using this front slide micrometer. And now this line is coinciding with this line. It has moved. I have moved this thread upwards so that this line is coinciding with this, and now the reading is almost 0. It's almost 0. That is
no question of almost. What is the exact reading? You have to say that.
It is 0.
0.00. You're right. 0.00.
So now you need to calculate the difference, but as it is 0, so the major diameter is 4.28 mm. And similarly, you calculate minor, and the pitch length. Pitch length is calculated using this cross slide vernier. You need to adjust. You need to use this cross slide micrometer, and you need to use this vertical reference line to measure this. And coming to the angle.
First, how you do that? You explain here.
And you need to bring this vertical
Crosshair.
line on approximately the center of this
At the peak.
Peak, and then you need to check again. You need to check the initial reading. Then you need to move your cross slide on the rightward. You need to move the thread towards left such that this comes here, and you take the next reading, final reading, and you check the difference, and you'll get the pitch. And coming to the angle, you have a 360-degree measurement here. It's eyepiece protractor, and you have this facility of moving your CV coinciding vernier scale up and down depending on your like comfort zone. So you can also lock it also. Then I'll set it here, and to measure the angle, again you need to use this vertical line, and you have your thread like this. You need to adjust these vertical lines such that when you rotate your eyepiece protractor, it should coincide. Let us consider that my vertical line is coinciding with this, and when I rotate it clockwise, it should coincide. This vertical line should coincide with the next line. So after that, you need to measure, and you need to check this initial reading and this final reading, and the difference will get you angle, and the least count of this thing is 12 minutes, and you'll get the angle. And this is now once you calculated all this thread specification, as this is a standard thread, we have the standard values, and you also calculate the deviation of the error, and you can also calculate this to this these micrometers. You can calculate all these micrometers. And coming to the
Calibrator.
You can find the errors of all these 3 micrometers also. You can find the deviation. Then coming to the application, it is as we've done, it is used to check the thread reading, thread specification and all. And one more important application of this is as in this setup we have something like this in our eyepiece, but there is something called master thread profile. So when you look at the eyepiece, you see this master thread. This will be your eyepiece. And when you have your actual model, and you place it and you look at the eyepiece such that it coincides. So this is checked whether the manufactured thread is perfect or not. This is one of the important application of toolmaker's microscope. And also it's also used to calculate the relative position between the points. Once you have a piece which has to be moved in your manufacturing process, so that you use this, since your workpiece is so small, you use toolmaker's microscope and determine the relative point, and you determine the length, and you give that feed to whatever machine you have, so that the point B comes to point A. So that is also